Hello there, our wonderful and esteemed viewers on your favorite mathematics YouTube channel, Mathematics by Zeno. That channel is specially created for you and I to come together to tackle mathematics and demystify the age-long phobia often associated with this all-important subject, one topic at a time. Today we're looking at a topic that has to do with further mathematics, and that is differential calculus. To start with, when we say calculus, it's a broad topic that entails essentially two branches, and these are differential calculus, popularly called differentiation, and integral calculus, popularly called integration. However, the purpose of this video of ours is to look at differential calculus, or simply put, differentiation. So when we say differentiation, what comes to mind? In the student's parlance, you often hear the expression dy dx. That exactly is differentiation. When you say differentiation, basically, you are studying the rate of change of one quantity with respect to a related other quantity. In most cases, it's y and x, hence the name dy dx. That's not to say that there can be other two variables being compared. In the parlance of economics, we can look at the rate of change of quantity of a product being demanded vis-a-vis the price. Hence, we talk about the Q, the P, that is rate of change of quantity with price correspondingly. And in physics, we can say rate of change of velocity with time, that is the V, the T, and so on and so forth. So what exactly do we understand by the concept of differentiation? To start with, when you say differentiation, there are several expressions that can be used to mean the same thing. If you are given to start with a function y in terms of x, you can be asked to differentiate y with respect to x. That's the WRT, with respect to x. You can be asked to find the dy dx, which is a more popular expression, and you can be asked to find the first derivative, or in some cases you can be asked to find the first differential coefficient. These are basically what is meant by differentiation or differentiate. So, to start with, we look at a simple table of basic differentiation. Here we have, if you have y as our function in terms of x, what will be the corresponding differentiation to y dx? To start with, we have the algebraic expression ax to the power of n. Here, we are going to have n times ax power n minus 1 after differentiating. If you have a trigonometric function, sine specifically, after differentiating, we're going to have cos x. If you have cos x as the function, when you differentiate, you're going to have minus sine x. And if you have tan x to start with, on differentiate, you're going to have sec squared x. Now, if you have a constant, differentiating gives you 0, and so on and so forth. At higher level, you have exponential function, which technically seems to be this. We have explanation there. And if you have a logarithmic function, either log x or ln x, you're going to have 1y. Again, this is subject to further explanation. So essentially, these are the tables of differentiation that we have to start with: algebraic, trigonometric, a constant, exponential, and logarithmic. So you must bear this in mind in every question you are going to be solving. Without wasting time, let's take our first few questions. So we got Find the divided x for each of the following. To start with, if y is 6x squared minus 5x plus 7, 2, you've got y equals 7 root of x plus 9 over root of x minus 4 over x. And then 3, if you've got y equals 5x squared plus 4x minus 11 over 2x squared. Okay, you take this 3. Now, solution 1. We have y is equals 6x squared minus 5x plus 7. This is the original question, y. So if you have to differentiate, these are exclusively written in terms of algebraic. So bear in mind, from the table, you just say divide x. That is differentiating y with respect to x. All you need to do is to multiply the exponent of the x with the coefficient. So 2 by 6 is 12. You have x, then 2 minus 1. From that table, remember, you've got ax power n transforming to n ax power n minus 1 on differentiating. So this is a, this is n. So n times a, which is 12, n minus 1. So after differentiating, you take any one from the exponent. I'm done with that. And the exponent here is actually 1. So that's going to become minus 5. And we have x, 1 minus 1 is 0. This is a constant, which means you're going to have 0 when you differentiate. And the answer is 12x minus 5. Because x power 0 is 1. And that is the solution to the first problem, which I believe you found quite straightforward. Moving on. Question 2. You've got there that y is equal to 7 root x plus 9 over root x minus 4 over x. Now, before you proceed, you must try to express each term in terms of indices, as the case is in question 1. We have here, they are separated by plus and or minus, and then each term is written in initial form. We have roots here, this is not yet in indices, so express this as indices. So that means we write in this actually 7x power half plus 9x power minus half minus 4x power minus 1. So this is exclusively written in indices now. It's only then you can go ahead and differentiate. Take note, I have not differentiated at this line. I merely re-express the question in initial form. Then you can go ahead and differentiate. So half times 7, that's 7 over 2x half minus 1. Don't forget to always subtract 1 from your power after you are multiplying the coefficient. Then you're going to have minus 9 over 2x minus half minus 1 minus 3 over 2. Then here it's going to become plus 4x minus 2. And that's the solution of differentiating y with respect to x for question 2. If that is clear, which I believe it is, let's take the very last example on the board. Here, example 3, we've got y equals 5x squared plus 4x minus 11 over 2x squared. Now, recall from the last example that before you can proceed to differentiate, two conditions must be met. One is that each term must be standing alone. I call them standing alone. They are not lumped up. If you look at question 1 and 2, look at 6x squared separate, minus 5x separate, and 7 separate. Likewise this. That's condition 1. Condition 2 is that you must have each standalone term in indices form, in index form really. So here, they are lumped up because we have the numerator divided by 2x squared. So we try to separate, to detach them. So here we write first. We don't differentiate right away, we rewrite. So you're going to have 5x squared over 2x squared plus 4x over 2x squared minus 11 over 2x squared. Yeah, that's step 1, to disaggregate the terms. The next thing is to express them in indices, which is the second condition. That's going to become 5/2 because x squared crosses out x squared. Then here we have 2x minus 1 because 2 in 4 is 2. Then lastly, minus 11/2 is x to the power minus 2. Please, we can't bring these two up. We have numbers and then indices. Now, we have achieved the aim of having the terms separated as standalone and then they are written in indices form. We can then proceed to differentiate. Hence, dy dx from that point will be, of course, it's the constant. And that means that's 0. Then differentiate this, we're going to have minus 2x minus 2. Please, again, once you multiply, don't forget to take away 1 after. The minus 2 times minus 11/2, that's going to be plus 11x minus 3. And that is the end of the solution. So differentiate simply means you find rate of change of y with respect to x. And with that, we come to the end of today's lesson, which has got to do with a very basic introduction to differential calculus, or popularly called differentiation. So we'll be able to tell us that dy dx is one of the ways of asking you to differentiate a function with respect to a given variable. And it can also be asked to find the first derivative or first differential coefficient. They all mean the same thing, really. And what that to say is to tell us that we should determine or study the rate of change of function y with respect to the variable x. And with that, we come to the end of today's class, which I believe you found quite interesting. It's just the introduction. And this is a stepping stone to greater and more interesting form aspects of this topic. Thanks and stay blessed.